On our first problem, we have Laplace of integral from 0 to t minus tau times e raised to tau d tau. So this can be equal to Laplace of integral from 0 to t f times t minus tau times g of t d tau. And to plug in our equation, we have Laplace of integral of 0 to t minus tau times e raised to tau d tau. This can be equal to integral from 0 to t f of s over s minus 1, where f of s over s minus 1 limit of 0 to t. And our final answer is f of s over s minus 1. Second problem, which is number 3, we have the Laplace of integral of from 0 to t of t minus tau times cosine of tau d tau. So in our formula, we have Laplace of f of s times g of s. So to write this, we have Laplace of integral of from 0 to t f of t minus tau, as there is cosine of tau d tau. This can be equal to Laplace of integral from 0 to t minus tau times cosine of tau d tau. And we have integral from 0 to t f of s times cosine of tau is equal to s over s squared plus 1. So this can be equal to s of f of s over s squared plus 1, limits of from 0 to t. This can be equal to s f of s over s squared plus 1. This is our final answer. Number 5 problem, we have Laplace of t squared convolved with t cubed. So our t squared is equal to 2 factorial over s cubed multiplied by t cubed is 3 factorial over s raised to 4. So to multiply this, the answer is 12 over s cubed times s4 is equal to s raised to 7. So this is our final answer. On our number 7 problem, we have inverse Laplace of s over s squared plus 4f of s. So this can be equal to cosine 2t times t minus tau plus 2 cosine 2t convolved with t minus tau. So in our formula, we have integral from 0 to t f of t times g t minus tau d tau. So to input are given, we have integral from 0 to t cosine 2t times t minus tau d tau. So we have tau t cosine 2t multiplied by t tau minus tau squared over 2, limits from 0 to t is equal to t cos 2t times t minus t squared over 2 minus 0 cosine 2t times t 0 times 0 minus 0 squared over 2. This can be equal to 0. So left is t cos sine 2t times t squared minus t squared over 2. This is equal to t cosine 2t times 1/2 t squared. For final answer, we have t cubed cosine 2t all over 2. This is our final answer. For our last problem, number 9, we have inverse Laplace of s over s squared plus 4 all raised to 2. So we can write this as inverse Laplace of, we will separate 1 over s squared plus 4 times s over s squared plus 4. This can be equal to, we will multiply 1/2 so that we can have inverse Laplace of 2 over s squared plus 4 times s over s squared plus 4. This can be equal to 1/2 inverse Laplace of 2 over s squared plus 4 is equal to sine 2t convolved with, this can be equal to cosine 2t. And for our formula, we have integral of from 0 to t f of lambda g times g t minus lambda d lambda. So to input our given equation, we have integral from 0 to t 1/2 sine 2 lambda times cosine 2 t minus 2 lambda d lambda. So in our trigonometry, we have our sine a plus b is equal to sine a cos b plus cosine a sine b, and our sine a minus b is equal to sine a cosine b minus cosine a sine b. And to multiply sine a plus b times sine a minus b, this will be cancelled out. So we have the sine of a plus b plus sine of a minus b is equal to 2 sine a cosine b. So we will divide this into 2 so that we can have we can divide this in 4 so that we can have 1/2 there. 1, this is 2. So we can have the sine of 2 lambda plus 2t minus 2 lambda plus sine 2 lambda minus 2t plus 2 lambda divided by 4, and this will be cancelled out so that we have we'll take out 1/4, and we have integral from 0 to t sine of 2t plus sine of 4 lambda minus 2t d lambda. And we will let's take the integral so that we have this can be equal to 1/4 times lambda times sine 2t minus cosine 4 lambda minus 2t all over 4. The limits of from 0 to t. And we will substitute upper limit to lower limit so that we have t sine of 2t minus 1/4 cosine of 2t minus 0 minus cosine minus 2t over 4. And we will cancel, so left we have 1 over 4t sine 2t, and this is our final answer. This lesson, it teaches me the convolution theorem, and based on videos and given calculation activities, it helps me to enhance my knowledge in solving differential equations using Laplace transform. And also, it helps me to familiarize and solve other forms of Laplace transform.